Hello, in today's video I will show you how you can create Mitred Elbow in Autodesk Revit, following few simple steps. Also, I'm going to show you how you can optimize your workflow with these kind of components. As always, all the materials can be found on our website, together with our templates like a share parameter file, lookup table, Excel sheet, 2 connectors family and 3 connectors family templates. For this exercise, I'm going to use 2 connectors family. So, let's get started. We will create new family using the template that I just downloaded. This template consists of a few default properties together with a few default values. We need to update it slightly because in this exercise we will cover only one size range. It will be 10 inch, but of course it will adapt automatically depending on how much data you will have in CSV table. Here I will also clean up for a bit. And that's it. Now we are starting with the geometry. As always, we need to add radius property or radius constraint, and also we are going to use our B coefficient to define the center line of the elbow. So first we'll start from B, then we will define radius, I'm going to adjust it to the values that we are going to use it. .75. Oh. Yes, 10.75. Oh, wait, actually I mislooked it. It will be 70.25. This one I will extend over here. And now, of course, when we know the value of the radius, we also need to define the angle. For now, let it be 90. Oh, of course. We also need to select proper values, proper units. So it should be angle 90 degree. So yeah, now let's define the formula. As always, it will be equal to r multiplied by tangents of angle divided by 2. This simple formula. And now actually we can start with the geometry. To create this kind of elbow, we will use sweep tool, and we will start with the path. Path, of course, will be based on the polygon. In my case, I would like to have 16 edges, and I'm going just to start to draft it. I will remove all unnecessary parts. Then also will add some constraints to it. And of course, I need to add some additional dimensions to ensure that it's always will be the same. this one, and this one. It should be equal to the radius. Also, do not forget to add angle constraint, just to ensure that those lines always will be on the right spot. Just add lock here. Ensure it's blocked. And this is it. It's all about the path. We can close it. And now we just need to add the profile. Profile we can create from the front view. First of all, we need to identify that it will be diameter, indicate that it will be diameter. Then we can link it to the outside diameter. And this is it. To make my life easier, I will just copy it and we'll modify it slightly, and we will use it as 45-degree Mitred elbow. So we'll use same constraints here. Also, we need to link them to the radius. Okay. And okay. Finally, we can add additional reference plane to indicate the angle. We can extend this line a bit just to make sure that it's connecting to that. Correct. Here I'm going to double check if this was defined correctly. Yes, now it should be fine. Then I will adjust the angle to match 45-degree. And then I'm going to adjust this one to ensure that it's having the same value. And right now we are finished with the Mitred elbow geometry, and we are going to add some features to trick Revit. Because it doesn't matter what you will do, you will never be able to get the dynamically the path adjusted. So you will never could have, as for example in comparison to the regular elbow, different kind of angles with the same shape. So that's why you need to create separate shape for every angle. But probably you will ask how then we're going to handle the geometry and creation of the elbow itself and the connection to the piping system. That's a nice question. And to that, we will simply draw the regular elbow. As we know, we need to add center mark. First one, second one. Then add some constraints. And of course, define the profile. We need to add one more dimension. Link it. And we're almost there. Now we just need to isolate this elbow that we just added. And we will use it to determine the connection to the pipe. So now I can make it equal to the DN. Yes, like that. Then I can also link them, ensure that both of them associated with fittings, and angle also connected to the angle property. The last step to ensure that it's working, we need to ensure that this connector will be always primary one. So I'm going to just click on it and ensure that it's primary. Yes, now it was set as primary. How to understand which connector is the primary one? You can just click reassign primary, and if you will see such a symbol, actually the selection of the primary connector, then you know that this connector was the primary one, and you can just reselect it. So that means this one will be always primary connector. Then we can reset the temporary hidden components, and we're going to add two visibility properties. First one, we'll make it simple 45 degree, and the second one 90 degree. And basically that's it. Now we just need to add a few properties. Now we just need to add a few expressions. So in case when a less than 46, it should be 45 degree elbow, and if it's more than 46, it will be 90 degree elbow. This is what you also will see immediately in the model. And additionally, we need to ensure that this shape will be always hidden. So we just need to disable visibility for this component. And from geometry point of view, this is it. We will take care of the lookup table. I have already created it in advance. So what do we have here? Two values for nominal diameter for the first and second connector. Angle that I'm using as a coefficient. In this case, we will not use it. Then thickness on both ends. Outside diameter value, radius, and the weight. In this case, weight will be empty because we're not following any kind of standard. Then we have name or description of the component, standard that we are following, material, pipe specification, item code, object type, PCF key, schedule, end type first and type second. Same for pressure ratio and facing. These attributes will be essentially and mandatory for our PCF plugin. Otherwise, you cannot have decent isometrics as a result of the PCF export. Now I just need to save it as CSV. And we can import it to our family. I will also remove. Here it is. Then I click on OK. And as always, we need to mention that we would like to use this table. In my case, I will just reopen Excel sheet. You can also do that to see the reference. The names of the columns that you defined over there. In my case, I also have here some hints how the lookup table should look like, and I can just copy paste it. Yes. And now we can adjust it. What will be important to mention that here we also need to add one extra property. I will call it coefficient, and I will use it to define the description of the component. As you remember, in the table itself, I had this 4 and 6. In this case, 4 represents 45 degree and 6 represents 60 degree, 90 degree elbow. So we're going to use it also right now. So here, if A less than 46, then it will be 4, else 6. And here I'm going to add it as an extra search criteria, and I'm going to add it everywhere. Just to remind you, the searching is always happening from the left side, and you always need to make it one by one. Do not try to place search values in between the result values, because it will never be working like that. It always should be from left to the right. From the left side you have all the search values, and from the right side you have result values. Now we can take care about the description kind or text kind attributes. In this case, it will be end one facing. I can also use it over here. Then we will do the same for pressure ratio. And for the end type, in this case it will be butt weld. I'm just going to copy paste it here, and I will adjust it to end type 1. End 1 type. End 1 pressure ratio. Then we will take care about the PCF related properties. Then it will be key. And then it will be spec. Then we will take care about the description, standard, material, and etc. So description. Then it will be standard. In this case it's empty, but in your case it will not be. Material. Manufacturer. It's not an object of our manufacturer is not an object of our CSV table. So then it will be standard. Oh, pardon, then it will be material, one of the last ones. And the schedule. Now, of course, item code too. Item code only if it's necessary. In your case. And then this is it. The family was created. We can adjust the type name. For example, to 160 PCI. Okay. And now we are ready to test it. I'll just close it, create new project, in parallel system templates, systems template. Then I will load it into this project. And we are going to modify one of the pipe types. It will be chilled water. I will just add one extra elbow row. We'll define our newly added family. I will change the size range that's covered by the existing pipe type, and I will just add it. Click on apply, okay, and we are ready to draw it. Now I just need to select 10-inch, chilled water, change the model to fine level, and I will disable one of the plugins I have here. Now, as you can see, in case of the 45 connections, it returns 45 elbow, Mitred elbow of course, and in case of the 90 degree, it should return 90 degree elbow, but somehow it's not the case. Okay, let's this is weird. Probably something was not saved properly, because this connector was not the primary one. Right now when I reassign it as a primary connector, it's working. Okay, good. So the solution was simple. And now, as we can see, we can have two kind of elbows from the same family, despite the limitations because of the geometry. Great. Well, thank you for watching. As always, all the materials will be uploaded to our webpage. Here you also can see all the templates that we are using and will be using in coming videos. All the support materials also will be uploaded in the section under the video, so you can easily access them and download. Thank you for watching, and see you next time.